Hello everyone, today our group is going to present how we use the decision tree model to help decide between purchasing an electric car or a gasoline car. To begin with, a decision tree is a flowchart-like structure that helps make decisions by splitting the data step by step. Based on different features, it's a simple yet powerful tool often used in classification problems. Next, let's go through the main components of the decision tree. The root node is where the decision-making process starts. It's the very first question asked. Then we have internal nodes, which are used to further split the data based on conditions. Finally, we reach the leaf nodes, which present the final decision, and in our case, either electric or gasoline. Now, how does the tree decide which features to use at each step? That's where information gain plays an important role. It helps the model choose the most useful feature by calculating how will each one separate the data. The higher the information gain, the better the speed. This contributes to overall accuracy of the model. After that, we use a dataset where each entry ends with either an electric or gasoline car. That's the output we want our tree to predict. On this slide, you can see some details about our data. In total, we have over 200 rows and 5 input features: commute distance, income level, fuel price concern, environmental concern, and car preference. For example, one training entry says more than 10 kilometers, no, high, yes, electric. This means the person commutes more than 10 kilometers, has no high incomes, cares a lot about fuel price and the environment, and ends up choosing an electric car. Our model learns patterns like this across like whole dataset to make predictions for new users. To keep things simple, we've shown just 3 sample entries here, but the model was trained on the full dataset.
In this section, I will walk you through the steps to build a decision tree for my project using AISpace decision tree version 4.4.0. Let's assume that we already downloaded the program file, and it is right here. We will go ahead and open the program. After creating the dataset and saving it as a text file right here, we are going to create new dataset, and then I'm going to enter all of our parameters and then OK. Next, we are going to load the datasets, the one that I show you. Sorry, this one. And then I'm going to check that all of the parameters were correctly detected and all the training example appear. Then I will click View Edit Example to manually move a few examples, like the few example of training data to be the test data sections, which will be used later in evaluating the model. And first, I'm going to remove this row because they are all headers. Electric, gasoline, electric, and gasoline. Okay, close. And then after loading the datasets, before I generating the tree, I open the decision tree option menu right here and go to splitting function. I change it to information gain. This method helps the tree choose the best attribute to split on based on how much information it provides. It's like a common technique in decision tree learning. And then I click solve and auto create. Okay, and now the tool generated a tree with 15 nodes, 7 split, and a maximum depth of 4. This structure reflects how the model split the data using the most informative attribute first. Okay. After the tree was created, I rearranged the layout manually to improve readability, which I placed it in the presentation. This one. This makes it easier to follow the decision path and understand how predictions are made based on the input data. And I'm going to show you the result, the test result right here. Our model can predict it correctly 100%.
Now, let's look at the final decision tree and how it makes predictions. First, the root node is commute distance. That's a very logical starting point, because people who travel less than 10 kilometers each day usually don't worry about battery life, so they tend to choose electric cars. If the commute is more than 10 kilometers, the tree checks fuel price concern next. On the left branch, for people traveling more than 10 kilometers, if they don't care much about fuel price, they usually choose gasoline cars. 10 of 10 in our data. If they do care, the tree looks at their income. If income is high, most of them, about 73%, pick electric cars, probably because they can afford them and want to save fuel in the long run. If income is low, it goes one step deeper, checking if the person cares about environment. If yes, they choose electric. If not, it predicts gasoline. On the right branch, for people commuting less than 10 kilometers, if their income is high, the model is very confident. 90% of them pick electric cars. If their income is low, it checks fuel price concern again. If they don't care, they still go for electric. Maybe because short trips don't need too much fuel. If they do care, the final check is environmental concern. If yes, then will be electric, and if no, will be gasoline. In short, the tree uses commute distance as the first feeder, then combines fuel concern, income, and environmental values to predict the final choice.
In this project, we use a decision tree model to predict whether a person is more likely to choose an electric or gasoline car based on everyday factors such as commute distance, income level, fuel price concern, and environmental concern. We built our model using AISpace decision tree version 4.4.0 by applying information gain as the splitting method. We created a tree that is simple, interpretable, and easy to follow. The structure of the tree is not overly complex, which makes it ideal for clear decision making. Its prediction can be made by answering just a few logical yes/no questions. After training the model on a carefully prepared dataset, we tested it and achieved very high prediction accuracy, showing that the decision tree learns the patterns effectively and can generalize well to new cases. This project highlights how even a basic decision tree can provide valuable insights and reliable predictions when the data is thoughtfully designed and well balanced. Thank you for your listening.